We have learnt about rational numbers, kinds of rational numbers which are terminating, and second kind is non-terminating or recurring decimal fraction. After these we have irrational numbers. So the numbers which are not written in the form of terminating decimal fraction or non-terminating decimal fraction, even or recurring, the numbers which are not included in this category, these numbers are called irrational numbers. For example, if I will take the answer of square root of 2, the answer will be 1.41421356. Neither number is terminating here, nor block of digits they are repeating itself. You can see here the answer. So such type of numbers, these are called irrational numbers. You have to keep in mind what are the irrational numbers. The numbers whose decimal fraction is neither a terminating decimal fraction or a non-terminating decimal fraction or recurring decimal fraction, and those types of numbers, these are called irrational numbers. Examples are in front of you. Answer of under 2 is like that, and pi, we know about this figure. The value of pi is 22 divided by 7. When you will divide 22 by 7, you will get the answer like that, 3.14, like that. So no number is repeating itself, neither we can see the block of numbers are repeating itself, so it's an irrational number. The other examples are under root 3, under 5, and so on. You will check them, and so you can say that these are irrational numbers. Now, one question they will ask you in your exam, that express this decimal fraction, any decimal fraction. For example, here is 0.3 bar in the form p over q, where pq belong to set of integers, and q is not equal to 0. So how can we prove it? First of all, when we have to do the solution, we will suppose x is equal to 0.3 bar, so it can be rewritten as 0.3333, so on, right? Now if I will multiply both sides by 10 of this equation 1, so I will get 10x is equal to something like that. After multiplying this, you will get the answer same, it will be 10x, right? Now subtracting this equation, I will call this equation 2, subtracting equation 1 from equation 2, you will get 10x minus x on left hand side and 3.333 minus 0. Like that, it will give you 9x, and here 3.33 or 333, whatever you will take, 43 or 33 after decimal point, it will give you answer 3, because all will be 3.00. Now x is equal to 3 by 9, and your answer will become 1 by 3, which is rational number, and its form is of p over q form, and condition pq belong to set of integers and q should not equal to 0. So your this decimal fraction can be written in the form PQ belong P over Q, where PQ belong to set of integer and Q is not equal to 0, and this is its solution. It's so simple, so interesting, and in this way you can write the decimal fraction in the form P over Q, and you can show that this decimal fraction is a rational number. They can ask you a different question. They can ask you 0.23 bar, 23 will repeat itself, and similar you will do like that. You will suppose x is equal to 0.23 bar, and then you can write it here, x is equal to 0.232323, so on. Name this as equation 1, multiply this by 10, and then you will subtract one equation from 10x second two equation. When you will take away, you will get the same answer like that, and you can show that your given decimal fraction can be written in the form P over Q, and PQ belong to Z. You have to mention these two conditions, and Q is not equal to 0 at the end, and in this way you can do the solution. It's so simple.